Hello, geometry students. This is your teacher, Mr. Pouts, here for video for section 1.4, 1-4, about measuring angles. Last section we talked about measuring segments. Now we're going to get the basics on measuring angles. Talk about a few different types of angles. So your goal to write down for this one would be to find and compare measures of angles. Find and compare measures of angles. All right, so we got a few different vocabulary terms to talk about with this as well. Let's start off with the main definition that we need to talk about, and that's angle. What is an angle? You probably can picture an angle. You can kind of find angles. You can probably describe angles. Let's be specific with a few things about angles. So the definition of an angle, and maybe you know this, but it's really just two different. Here we go. We'll say two different rays joined by the same endpoint. There's actually three different ways you can name an angle. So we talked about different ways of naming points and lines and planes, but to name an angle, you can name it you can name it by the vertex. And the vertex is that point right there, and there's probably going to be that's a point, so it'll always be labeled by that point, which in this case would be angle A. Second way is by a point from each ray and the end point. So that would be like angle BAC. Or you could also say angle CAB. So we got this way right here, this way right here, and we're going to do one more way here. The other way to label an angle, it would be by a number. A lot of times you'll have a number inside of the angle, and this would be angle 1. Okay? So let's talk about naming angles. Examples, name the angle in 4 different ways. So let's do angle 2, that's the number. Angle S, that is an S, by the way. That is the endpoint, or the vertex. And we can do angle RST, or angle TSR. Next question is name the vertex. So identify the vertex, and that would be that point that is both the endpoints of the two rays. So that would be S, and the sides. So the sides are both rays. Remember. So we have ray SR and ray ST. Now I don't know if you noticed this when we first were introduced to rays, but labeling them, it does matter the order of the letters. So you always start with the endpoint and you work your way out. So the order of it goes SR, and it kind of goes with how you do the arrow as well on top. So they both start with S because they both have the same endpoint of S. All right, example number 2, name all the angles having W at their vertex. So it looks like we've got 3 different ones, and I'm going to label the first 2 of them the easy way, angle 3 and angle 4. You could also say that would be XWY or YWX, and YWZ or ZWY. And the last one is angle XWZ or ZWX. Okay, those are the 3 angles with that as a vertex. All right, next part. An angle separates a plane into 3 parts. The blank of the angle, the blank of the angle, and the angle itself. So you can probably figure this out by what's down here. We always have the interior, the exterior, and the angle itself. Oops. So what does the interior all consist of? Well, it's everything that's inside of the angle itself. Now, technically, if we say angle ABC, that could be this inside angle or this outside obtuse angle. But we're going to go within the smaller of the two angles. And if it's a straight angle, then there is no inside or outside to it. So interior points, we have G and E. Obviously, those are inside of this smaller angle. And the exterior points would be D and F. And then those three other points are all on it, A, B, C. All right? So moving on, if I'm going too fast for you, just slow it down, pause it, and take a look and see if you have any questions. You can circle those, bring those to class the next day. Otherwise, use your online textbook to see if you can answer any of those questions as well. But moving on, talking about measuring angles a little bit. Measuring angles is something that you should have learned up to this point. One of the few tools you use in just geometry itself would be a protractor. And so right here it says angles can be measured in units called degrees. I hope that's not new for you. We're gonna be using a lot of we're gonna use angle measures and degrees a lot this year. And that protractor is what you use to find the measure of an angle if you're just measuring it with a device. And don't get that confused with a compass. A compass is what you draw circles with. So if you were to take this thing, and I'm not sure if this one is in your notes or not, but I'm going to grab my little, grab my little compass here. See if I can make this bigger. I think I can. Well, it's not working the best for me right now. But I'm just going to estimate that's probably about 45 degrees. We'll measure some below here too as well. But classifying angles, again, this should be review. Other than this first one you might not remember. An angle that is 180 degrees, or the equivalent of a straight line, is called a straight angle. Good name for it. It's a straight angle. Okay, and then the rest of these should be reviewed. 90-degree angle, that is a right angle. Less than 90 degrees would be acute, and greater than 90 degrees is, of course, an obtuse angle. Okay, make sure you know those. All right, here's some measuring. There's some angles on here already. It says use the protractor to the right to find the measures of the indicated angles, then classify as acute, right, or obtuse. So sometimes you'll find that if it's not lined up with the zero, you have to do a little subtracting. But this first one, BAD, looks like that is about 98 degrees. And that is greater than 90, so that would be obtuse. Measure angle CAE. So C, vertex is always going to be A, and E. It goes from 59 to 174. 59 to 174. So we can do 174 minus 59. Or is it 174 minus 59? So that 174 minus 59 would get you to 160, I believe. Or sorry, 115. I don't know where that came from. 115. And that, of course, is obtuse as well. Let's look at angle EAF. So EAF. And that's just going from number 174 to 180. So that's 6 degrees. And acute. Last one. Hopefully you're already up to this one. Would be CAD. Right here. Looks like that goes from 59 to 98. And that would be, so 98 minus 59, I believe it's 39 degrees. And that one is also acute. All right, so that's just a little bit working with a protractor and measuring angles themselves. Now we're going to go on and we're going to talk just about this one postulate. It's postulate 1.8. It's called the angle addition postulate. It's kind of similar to the segment addition postulate in that it reads, if a point B is in the interior of angle AOC, then we can say that angle AOB plus angle BOC would be, since we're not talking about numbers here, we're just talking about the angles themselves, they would be congruent to angle AOC. Now you could also say the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC, because those are dealing with numbers or values, the measure of something, right? Okay, so number 7 here, it says complete the statement. Angle DFB plus angle, or the measure of angle DFB, sorry, equals the measure of angle 2. So DFB would be a measure of angle 2 plus the measure of angle 3, correct? All right. And if these are too easy for you, you want to do them on your own, I would suggest doing them and just checking them with me. That'd be awesome. Number 8, though, if measure of angle 1 is 35 degrees and the measure of angle AFC is 85 degrees, this is 35. AFC, the whole thing there is 85, then this other part would be left to 50. So that would be 50 degrees. You'll find that if you don't label things, if you don't put degrees even, you won't get full credit. You got to be precise. All right, number 9. If the measure of angle 3 equals 2x plus 5 degrees, and the measure of angle 1 equals the measure of angle 3, so we can also say the measure of angle 1 is 2x plus 5. And then it's saying the measure of angle 2 is 2x plus 20. What is the measure of angle 1? So whatever it is, it's going to be the same as the measure of angle 3. So we know that the 3 of those will add up to equal, I'll show you that right here, this whole thing is a straight angle, so that adds up to 180. So we do 2x plus 5 plus 2x plus 5 plus, that middle one is 2x plus 20. Will all add up to 180 degrees. And then you just got to take it and, do some algebra. Simplify some things and solve. So those all will go together. We can add the 5s, 5, and 20 together so that you end up with 6x plus 30 equals 180. After you subtract 30 from both sides, you end up with 6x equals 150. And then x is equal to, when you divide both sides by 6, going up here, x equals 25. Okay, but that's not what the question is asking. We got that x equals 25, and we can put a box around x, it's important. But it says, what is the measure of angle 1? So the measure of angle 1, we said, oh, this was angle 1, would be plugging in for the 2x plus 5. So it would be the measure of angle 1 equals 2 times 25 plus 5, which would get you 55 degrees. And if you want to check that 55, then the measure of angle 3 would also be 55, and that's 110. And then we can check to see measure of angle 2 if you plug that in. 25 times 2 is 50 plus 20 is 70, so that would add up to that 180 degrees for that whole purple arc that we have here. Okay. All right, I got one more example for you. That's the last one. it says if angle XYZ is a right angle and measure of angle 1 is 4x, measure of angle 2 is 2x, what is the measure? What is the measure of angle 1? Well, we know that whole thing, that whole 6x would be equal to 90. So x, when you divide 90 up, would be 15 for each x. And since measure of angle 1 is 4x, 4 times 15 is 60. So the measure of angle 1 is 4 times 15, or 60 degrees. Okay, so that is our section on measuring angles. There's an error analysis problem and a closing question on your notes that you can answer, and bring any questions you have to class and be ready to do some work with this. All right, we'll see you next time.